In this lesson, we're going to learn how to use trig ratios to find missing measure sides, angles, or trig values. So I want to go over a few abbreviations. OPP is opposite. ADJ, adjacent. HYP, hypotenuse. Then we have SIN, which is pronounced sine, capital long I. COS, which we call cosine. And TAN, which is tangent. The first three we'll use to represent the different sides of a right triangle, and the next three are your trig ratios. As a quick review, when you have a right triangle, it has three sides, and they are designated as follows. The side opposite the right angle is the hypotenuse, and the sides that make up the right angle are legs. Okay? So when we refer to opposite and adjacent, we are referring to the legs of the right triangle. Okay? So our first ratio is going to be sine, and it is the ratio of the opposite side over the hypotenuse cosine is the adjacent side over the hypotenuse, and tangent is the ratio of the opposite side over the adjacent side. And we have a little mnemonic for that, and it's SOHCAHTOA. So if you can remember that, then you can go ahead and set up your ratios. So one of the things I do to make sure that I'm looking at the correct sides of the triangle is I highlight my hypotenuse. Okay? So we're going to look at sine. Sine is opposite over hypotenuse, and it depends on what angle you're looking at. If I'm looking at angle A, the opposite side measures 4, so my sine is going to be 4 over 5, opposite over hypotenuse. If I'm looking at angle B, the measure of the side opposite angle B is 3, so the sine of angle B is 3/5. But notice that both have the same denominator because it is the hypotenuse. So here we have a problem where we want to find the length of this side. It happens to be the side opposite the angle, so we're going to use sine. Our setup, sine of 37 equals the opposite, which is x, over the hypotenuse, which is 18. To solve this, we multiply both sides by 18. And then we plug this in the calculator, get 10.832. Since we're rounding to the nearest hundredth, I go out 3 decimal places because the hundredth is the second decimal place. And I need the next digit to tell me whether I leave that value alone or round it up. Since it's a 2, we leave it alone, and we get 10.83. Okay? Make sure when you're doing these trig problems that your calculator is set to degrees. Okay. Moving on to the next triangle, again, highlighting my hypotenuse, we're going to look at cosine. Cosine is adjacent over hypotenuse. The adjacent side is the side next to the angle, or you can look at it as the side that makes up part of the angle. So in this case, for angle A, it is 3. Again, the hypotenuse is 5, so the cosine of A is 3/5. If we go to angle B, the side next to it is 4, so the cosine is 4/5. Here we're trying to find the adjacent side, so we're going to use cosine. Cosine 42 equals x over 15. Multiply both sides by 15. Plug it in your calculator. You get 11.147. Rounding to the nearest nearest hundredth. Next digit is a 7, so this becomes 11.15. Last example on this page. We want to find tangent. Tangent is opposite over adjacent. So for tangent A, the side opposite is 4. The side adjacent to angle A is 3, so the tangent of A is 4/3. Moving over to angle B, the side opposite angle B is 3. The side adjacent to angle B is 4. And so the tangent of B is 3/4. Here we want to find the opposite side, and we're given the adjacent side. We don't have any information about our hypotenuse, so we know we're going to use tangent. Tangent of 29 equals x over 10. Multiply both sides by 10, and we get x equals 5.543. Again, rounding to the nearest hundredth, 5.54. Now, in these examples, it says if you know at least one angle on one side of a right triangle, you can find the other side. We're going to set up the same ratios. Again, I like to highlight my hypotenuse. Okay. So we have an angle and a side, and we want to find this side, which is the hypotenuse. Anytime you are given the hypotenuse or looking for the hypotenuse, you're going to use sine or cosine. You look and see what you're given. Since I'm given the opposite side, I'm going to use sine. Sine of 63 equals the opposite, which is 43 over x. Multiply both sides by x. Divide both sides by sine of 63, and you get 48.26. So in these examples, our x is going to be in the denominator. All right, so we look at example 2. Again, we have the hypotenuse, so it's sine or cosine. Since I'm given the adjacent side, I'm going to use cosine. Cosine 41 equals adjacent over hypotenuse. Multiply both sides by x. Divide both sides by cosine 41. You get x equals 63.600. Again, since we're rounding to the nearest hundredth, I need 2 decimal places, and I need to look at the digit immediately to the right. So my answer, 63.60. Because we're asking for the nearest hundredth, I have to have 2 digits in my answer. All right, example 3. We are not given the hypotenuse, and we're not looking for the hypotenuse, so that automatically becomes tangent. We are looking for the opposite side, and we're given the adjacent side. So we have tangent 53 equals x over 24. So again, we're going to multiply both sides by 24. we get 31.849. So our final answer would be 31.85. Okay, now, continuing on, again, I'm going to put my sign opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Now, in this part of the lesson, we are missing the angle. We have two sides, we're missing the angle, so we're going to use what's called the inverse tangent functions. So here we have x. Notice that we are not given any information about the hypotenuse. We're not trying to find the hypotenuse, so that means we're going to use tangent. We set up our ratio. Tangent of x equals opposite over adjacent. And this is where most of the mistakes are going to be made, not setting this up properly. So now that we have tangent of x equals 51 over 23, we take the inverse tangent, which this button is found on your calculator, and then it wants us to round to the nearest degree. So x is 66 degrees. Okay, moving on to example 2. We have the hypotenuse, so again, sine or cosine. We are given the opposite side, so that means we're going to use sine. Set up, sine of y equals opposite over hypotenuse. So y is going to equal the inverse sine of 43 divided by 48. We get y equals 63.6. Because we want to the nearest degree, I do need to go look at the digit in the tenths place. So since that's greater than 5, y equals 64 degrees. Example 3, again, we're given the hypotenuse, so it's sine or cosine. In this case, the other side that we're given is the adjacent, so that's going to be cosine. Cosine of c equals the adjacent side over the hypotenuse. We're going to take the inverse cosine of 30 divided by 35. This gives us 31.0. So C equals approximately 31 degrees.